In the last video, we saw how to find the sum of the squares of an AP. In this video, we are going to find a formula for sum of cubes of an AP. So let our AP be, suppose we have an AP, let our AP be A, which is the first term, A plus D, which is the second term, A plus 2D, which is the third term, A plus n minus 1D, which is the nth term, right? So we'll call this term as A1, A2, A3, and this term we will call as An. Now, before we proceed further, I want to clear some prerequisites that is required for solving this problem ahead. Specifically, I want you to look at what is a binomial theorem. Okay, for example, I want to find a plus b to the power n. N can be any value. Okay, it can be 1, it can be 2, it can be 3, it can be 4. So how to find a plus b to the power n? Actually, there is a binomial expansion which is given by this summation. That is, you find the NCI, a to the power n minus I and b to the power I, where C stands for normal combinatrix. Okay, but because we have not done binomial expansion as of now, so I will not deal with this formula as of now. So I will tell you an alternate way, an easier way, which is over here. So this is a Pascal triangle. How to create it? You write 1 here, then you start with 1, write 2 and 1. For the third row, you start with 1, then you add 1 plus 2, you get 3. You add 2 plus 1, you get 3, and you finish with 1. Then for the fourth row, you again start with 1, then you add 1 plus 3, you get 4. 3 plus 3, you get 6. 3 plus 4, 1, you get 4, and you finish with 1. For the fifth row, you have 1, then you add 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and 1, and so on. And you can continue building this Pascal triangle. So how is this helpful? For example, I want to find a plus b square. All I do is I refer to the second row of this Pascal triangle, because over here the power is 2. So I look at the second row, and then I write a square. This is my first term. Then my second term is, I look at this middle coefficient, it is 2. I reduce the power of a, it becomes a to the power 1, because over here first term was a to the power 2. If I reduce the power of a by 1, it becomes a to the power 1. And then I increase the power of b. Over here the b was 0 power, because b to the power 0 can be considered as 1. So if I increase the power of b, it becomes b, and then I write b square. What about a plus b cube? We follow the similar procedure. We start with a to the power 3, because over here the power is 3. Then I look at the third row and see what this number is. This number is 3. So I write 3. I reduce the power of a by 1, it becomes a square. I increase the power of b by 1, becomes a square b. Then I look the next number, this is 3 again, so I write 3. I reduce the power of a by 1, it becomes a. I increase the power of b, becomes b square. And then the next number is 1, so the last number is going to be, I reduce the power of a by 1, becomes 0, and if I increase the power of b by 1, it becomes b cube. And we see that we get the familiar formula for a plus b cube. How about a plus b to the power 4? A plus b to the power 4 can be written as a to the power 4, because it is 4 over here. Then I look at the fourth row, 1, 2, 3, 4, and I see 4 here. So I write 4. reduce the power of a by 1 becomes cube, increase the power of b by 1 becomes b. Then I look at the next number, it is 6. It a square, because I reduce the power of a by 1, increase the power of b by 1 becomes 6a square b square. Then I look at the next number, it is 4, and I continue with the same logic. Reduce the power of a by 1 becomes a, increase the power of b by 1 becomes b cube. The next number is 1, so becomes b to the power 4. So I hope you understand how to find the a plus b to the power n using the Pascal triangle. Why am I telling you this is because in the formula for deriving the sum of cubes of an AP, we are going to use the fourth power expansion. Okay, so for the fourth power expansion, you can see that it is a to the power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b to the power 4. And now we can go back to our original problem. So in the original problem, just like we saw in the sum of squares of an AP, we will write what is going to be a n minus 1. Okay, a n minus 1 is going to be a n. It is going to be a n minus the common difference, because each term of the arithmetic progression is only differing by the amount d, right? Now consider the expression a n to the power 4 minus a n minus 1 to the power 4. Okay, this is equivalent to a n to the power 4 minus a n minus d to the power 4. Now this I can write as a n to the power 4 minus, now you can see this is a minus b to the power 4. So we have already seen how to do the expansion of a plus b to the power 4. We'll just use that formula. This is going to be equal to a n to the power 4 minus 4a n cube times d plus 6a n square d square minus 4a n d cube plus d to the power 4, right? I have just put minus sign wherever the powers of d are odd, because if in a n plus d this will be positive, but in a n minus d all odd powers of d are going to be negative. So now we can see that I have written a n to the power 4 minus a n minus 1 to the power 4 all in terms of a n and d, right? So I know that a n to the power 4 minus a n minus 1 to the power 4 is equal to this a n, and this a n will cancel. This will be plus, right? Negative and negative is plus. So this will be equal to 4a n cube d minus 6 a n square d square plus 4 a n d cube minus d to the power 4, right? All we are doing is we are just simply following whatever we did. We are simply following the same procedure that whatever we did for sum of squares of an AP. If you have not seen that sum of squares of an AP, I would recommend that you watch that video first, right? Now once we know this, I can easily write what is going to be a n minus 1 to the power 4 minus a n minus 2 to the power 4. This is going to be 4 times a n minus 1 cube times d minus 6 a n minus 1 square d square plus 4 a n minus 1 d cube minus d to the power 4. And I go all the way up to a2 to the power 4 minus a1 to the power 4. This is going to be 4 a2 cube d minus 6 a2 square d square plus 4 a2 d cube minus d to the power 4. Right? Now if I add all this, what do I get? This will cancel with this will cancel with the next row, and similarly a2 to the power 4 will cancel with the previous row, and all you will be left on the left hand side would be a n to the power 4 minus a1 to the power 4. So you are left with a n to the power 4 minus a1 to the power 4. Now to this expression I also add 4 a1 cube d minus 6 a1 square d square plus 4 a1 d cube. I add these three terms to, that is, I add all the rows on the left hand side, and then I add these three additional terms. Why am I adding this? Because I see if I add this, then I have to add it on the right hand side also, and then this actually becomes 4 times a1 cube plus a2 cube plus all the way to a n cube, and this is what I want to find, right? So this becomes 4 times sigma ai cube I is equal to 1 to n. This is what we have to find. Okay, this is what we have to find. What is this term? This becomes minus 6 sigma of, I'm sorry, we are missing one term here. Yeah, this becomes, the first term over here becomes 4 times d, we have d here, sigma of ai cube I is equal to 1 to n. This is what we have to find, ai cube minus 6 d square sigma of ai square I is equal to 1 to n plus 4 d cube sigma of ai, which is normally the sum of the arithmetic progression, I is equal to 1 to n minus, how many times we have d to the power 4 here? We have n minus 1 times d to the power 4, right? So we have minus n minus 1 d to the power 4. Now this problem is very, very easy. We can calculate all the terms on the left hand side, because we know what is a n, we know what is a1. We know a n is a plus n minus 1 d, a1 is simply a. We also have derived the formula for the sum of squares of an AP in the previous video, right? We also know the formula for sum of the AP, which is 2a plus n minus 1d times n by 2. So everything is known in this equation except the sum of the cube of the AP. So if we bring all these terms to the left hand side and add it and divide it by 4d, we should be able to find what this sum is going to be. Now, because this involves a lot of algebra, I'm going to show you each and every step, but mind you, this is going to be involving a lot of algebra, so we will do everything in parts. Okay, so for example, I will be first solving only this part, then I will be solving this part, then I will be solving this part over here, and then we will add and finally derive the expression for sum of the cubes of an AP. Okay, so let us start looking at first the right hand side. Okay, sorry, the left hand side. We are only talking about this expression over here. Okay, let us simplify this. We know what a n is, right? So we know what this term is. This term is a n is a plus n minus 1d to the power 4. We know what is a1. We know a1 is simply a, so we subtract minus a to the power 4 plus a1 is a, so this is 4a cube d minus 6a square d square plus 4a d cube, right? And now we can expand this again using a plus b to the power 4. So this is going to be a to the power 4 plus 4 times a cube n minus 1 times d. Then the next term is going to be plus 6a square n minus 1 square d square plus 4 times a n minus 1 cube d cube, and lastly you will have plus n minus 1 to the power 4 d to the power 4, right, minus a to the power 4 plus 4a cube d plus 4a cube d minus 6a square d square plus 4a d cube, right? Now if you add this, so you can see that this a to the power 4 and minus a to the power 4 cancel each other. So what this will be equal to? This will be equal to 4a cube d can be taken out as common. So 4a cube d. Now this is n minus 1 plus 1. So this will be n minus 1 plus 1 is n. So this sum of these two terms, this term and this term, will be 4a cube d n. What about the next term? I can take 6a square d square common. So this is 6a square d square. Now what is n minus 1 square? It is n square minus 2n plus 1. And over here is minus 1. So plus 1 from this n minus 1 will cancel, and all you will be left with is n square minus 2n, right? because n square minus 2n plus 1 and then minus 1. So plus 1 and minus 1 will cancel and you will be left with n square minus 2n. I'm skipping some steps because I want to reduce the number of rows. You can do it in full expansion and see that you get this. Okay. Plus I can take 4ad cube common out. So this is 4ad cube. Now n minus 1 cube can be written as n cube minus 3n square plus 3n minus 1 and plus 1. So you'll be left with n cube minus 3n square plus 3n, right? And finally you would be left with d to the power 4. And what is n to the power 4? This is simply n to the power 4 minus 4n cube plus 6n square minus 4n plus 1, right? So now we see that we have the right hand side expanded. Now this right hand side expanded is equal to what? Is equal to 4 times d times, let us call this sum as s. This is what we have to find, 4 times d times s, right? Or let us call it s3. S3 means sums of cubes of AP, minus 6d square, 6d square S2. S2 is sum of squares of AP. Okay, this is S2. This sigma here is S2 plus 4d cube. Let us call this S1. Sum of AP is S1, right? So S1 is sum of AP, S2 is sum of squares of AP, S3 is sum of cubes of AP, minus n minus 1 to the power d to the power 4. Now you can see that we have d which can be cancelled out from both the sides, right? So I can see that I can take d as a common factor out on both the sides and cancel it, right? So this will be equal to, this implies that 4a cube n plus 6a square d times n square minus 2n plus 4a d square n cube minus 3n square plus 3n plus d cube times n to the power 4 minus 4n cube plus 6n square minus 4n plus 1. This is equal to 4 times S3 minus 6d S2 plus 4d square S1 minus, this will become d cube, so this is minus n d cube plus d cube, right? So far I think I have made it clear what this expression is going to be equal to. Now you can see that this plus d cube will cancel from here, d cube, right? I hope you can see this. So I will just rewrite this expression cancelling these d cubes. Okay, so if we cancel out the d cubes, that is if I cancel out this d cube and this d cube, that is d cube and d cube, will end up with this result, right? And now we will simplify it further. So now I will try to simplify the right hand side. So for simplifying the right hand side, let us first simplify what is this going to be. Okay, in the previous video we derived the formula for S2 as S2 is sum of squares of an AP, which is equal to n by 6 times 6a square plus 6ad n minus 1 plus d square into 2n minus 1 times n minus 1. If you want to see the derivation of this formula, I recommend that you watch the previous video. Now, if this is S2, what is 6S2 times d going to be? All I do is I just multiply this by 6 and d. So 6 and 6 will cancel and you will be left with nd times 6a square. Now let us expand it. The reason I am expanding everything is because we will have to collect the like terms and then simplify it, right? So this is nd times 6adn minus 6ad plus what is 2n minus 1 times n minus 1? It is 2n square minus 2n minus n is 2n square minus 3n plus 1. So let us expand it here itself. So it will be 2d square n square minus 3d square n plus d square, right? And now if I multiply it with nd, I get the first term is going to be 6a square d n plus 6ad square 6a d square n and n is n square, 6ad square n square minus 6a d square n plus 2d cube n cube minus 3d cube n square plus d cube n. Right? And what is so this is 6s2d, right? Now let us consider what is going to be the value for 4d square s1. Okay, now let us calculate the value of 4d square s1. We know that s1 is equal to n by 2 times 2a plus n minus 1 d, right? This is simply the sum of the formula. This is the formula for the sum of the AP. So what is the value of this? Implies that what is 4 d square s1 going to be? 4 d square s1 is going to be, we simply multiply this by 4 d square. So this is 2 times 2, so this is n d square, two n d square, and we multiply this by 2a plus n d minus d, right? And this is going to be equal to 4 a d square n, that is 4 a d square n plus 2 times n square d cube. So this is 2 times d cube n square minus 2 d cube n minus 2 d cube n, right? Now what is 4s3 equal to? 4 times s3 is equal to all this expression in red over here. So 4s3 is equal to 4a cube n plus 6 a square d n square, 6a square d n square minus 12 a square d n plus 4 times a d square n cube, 4 times a d square n cube minus 12 a d square n square minus 12 a d square n square plus 12 a d square n I agree that this is very hairy algebra, plus 4 AD plus 12 AD square n plus this term over here, which is d cube and 4 minus 4 d cube and cube plus 6 d cube and square, and I think we are falling short of space here, minus 4 d cube n, right? So this is 4s3, this red expression, plus 6 ds2, this minus will go here, so plus 6 ds2, so we have to add this term. So this is, let us use the same color that we used for this one, 6a square dn. We'll just write it wherever I find 6a square dn. So 6a square dn is matching here, so I write plus 6a square dn plus 6a d square n square. So this is over here plus 6a d square n square minus 6a d square n minus 6a d square n plus 2 times d cube n cube. D cube n cube is here plus 2 times d cube n cube minus 3d cube n square. So this is over here minus 3d cube n square plus d cube n. This is lined with this one plus d cube n, and I need to subtract minus 4d square s1. Okay, so all these thing here is 4d square s1. I need to subtract minus of 4d square s1. So all this will be multiplied by -1. So 4ad square n will become negative 4ad square n. So where is negative 4ad square n? It is over here minus 4ad square n plus 2d cube n square. D cube n square is over here. So plus 2d cube n square minus 2d cube n. I made a mistake because this is minus, so this will plus 2d cube n square will become minus 2d cube n square. Minus 2d cube n square, and this minus will become plus 2d cube n, which is actually aligned with this d cube n, plus 2d cube n. Now simply add this all up. So this means that we have 4 times s3 is equal to 4a cube n. Okay, so this term here 4a cube n. So we get 4 times a cube n plus 6a square d n square plus 6a square d n square. Now this is minus 12 and plus 6, so this becomes minus 6a square d n plus 4a d square n cube plus 4a d square n cube. This is minus 12 and plus 6, so minus 6a d square n square. This is plus 12 minus 10, so plus 2a d square n now this is plus d cube n4 plus d cube n to the power 4. Now this is plus 4d cube n cube minus 4d cube n cube plus 2d cube n cube. So this becomes minus 2d cube n cube now d cube n square plus 6 minus 3 minus 2. So you will have plus d cube n square, right? Plus d cube n square, then this is minus 4d cube n plus d cube n plus 2d cube n. So this is, I think we have left out one term from somewhere. Yeah, we have not yet included this term, right? We have not yet included this term. This term on going to the left hand side will become plus d cube n, right? Plus d cube n, and now you see that minus 4 d cube n plus d cube n plus d cube n and plus d cube n. So this is minus, this will cancel out completely. This is minus 4, this is 2, 1, 1. So that's it. So this is the final expression that you will get for 4s3, right? This is the final expression that you get for 4s3. Now I can take n as the common factor out. So if I take n as the common factor out, I get 4a cube, right? This is 4a cube plus 6a square dn minus 6a square d plus 4a d n 4ad square n square minus 6a d square n plus 2a d square plus d cube n cube minus 2d cube n square plus d cube n, right? And now we simplify this again. This is equal to n times 4a cube. I can take 6a square d as common, so say this is 6a square d n minus 1 plus d square, ad square I can see all the way here, so I can take 2ad square as common factor out. So 2ad square as common factor out, and you are left with, if I take 2ad square common factor out, we are left with 2n square minus 3n plus 1, and if I take d cube as the common factor out, in fact I can take d cube n as the common factor out, so this will become n square minus 2n plus 1, and therefore I can write 4s3 is equal to n times 4a cube plus 6a square d times n minus 1 plus 2ad square, not 2n square minus 3n plus 1 can be written as 2n minus 1 times n minus 1. Okay, this can be factorized, plus d cube n, and n square minus 2n plus 1 can be written as n minus 1 square. And finally we have the formula for S3, which is simply n by 4 times 4a cube plus 6a square d n minus 1 plus 2ad square 2n minus 1 times n minus 1 plus d cube n times n minus 1 square. And finally we are finished with this formula. So what is the special case? Special case we can consider as, okay, so what is a special case? Special case we can consider sum of cubes of natural numbers. Okay, so we can ask what is 1 cube plus 2 cube plus n cube. Now this is sum of an AP where a is equal to 1. So in this case a is equal to 1. And what about d? D is also equal to 1. So we just put a and d as 1. So we get sum of n cube as n by 4 times a is 1. So this is simply 4 plus a square d is going to be 1. So this is 6 times n minus 1. So this is 6 n minus 6 plus ad square is 1. So this is simply 2 times 2n minus 1 times n minus 1. So 2n minus 1 times n minus 1 is 2n square minus 3n plus 1. So you multiply this by 2. So this is 4n square minus 6n plus 2. D cube n is, d cube is 1. So this is n times n minus 1 square. So this is simply plus n cube minus 2n square plus n, right? So this is the sum of the cubes of an natural number. Now this we see that this is equal to n by 4 times we have n cube here. So we write n cube. Now this is 4n square minus 2n square. So this is plus 2n square. Now let us correct the terms of n. This is 6n minus 6n becomes 0, and then you have plus n. So this is plus n, and 4 minus 6 is minus 2, minus 2 plus 2 is 0. So this is n. You can take n as common factor out. So this is n by 4 times n square plus 2n plus 1, which is equal to n square n plus 1 square by 4, or finally we get the familiar formula sigma n cube is going to be equal to n times n plus 1 divided by 2, and we take the square of this term, and we are done. I think it was a pretty long video.